Hi, welcome to 505 Videos. This is DC here. In this video, I'm going to show you how to use Mifare Ultralight tag using PN5180 board. Now, these are things I would like to cover in this video. So I'll be focusing on the various PN5180 commands to work with the Mifare Ultralight tags. So I'll not be showing you or explaining the working of Mifare Ultralight because I have made so many videos which you can access from my YouTube channel. Now all these Mifare commands are added to the PN5180 Arduino library. So this is going to help users who do the embedded systems using this board. And the piece of software which I am using in this video will be calling these library functions. So I'm going to go through the code in the library and explaining what these command does, and also going to show you how the PC to Arduino interface program works. If you want to know how to work with Mifare Ultralight tags, you can visit my playlist, and if you go to YouTube and search for Mifare Ultralight, you will see this playlist. I made videos for different reader writers. So the first three is a more generic one. So here I've covered understanding the datasheet of Mifare Ultralight. So in this video you're going to see the following things. You're going to see how to activate the Mifare Ultralight tag. I have discussed about this in my earlier videos on introduction to PN5180, but in this video you're going to learn this in detail, going to the specific of the commands. You're going to see what are the commands used to read and write the blocks of Mifare Ultralight, and how to write the blocks. And you can write in a single step, or you can use a two-step operation which is compatible to the traditional Mifare classic write operation. You want to understand what is the ACK and NACK means and how to handle this in your code, and also how to send the halt command. So basically Mifare Ultralight has got only three commands. If you ignore the activation which is present in all the type A tags, so you have to learn how to read a block, write a block, and how to halt. In fact, even the halt thing is not very important. If you're most of the halt operations are handled by the reader writer. So basically you have to know the read and the write, and we're going to see various errors. So how to handle errors when you try to read an invalid page number or write to invalid page number, and how to write to what happens when you write to a locked page. So if you're using this board with your software, you will never come across a situation like this. So, and also you have to have a copy of the Mifare Ultralight datasheet, so which you can get from internet. So with this background, and now we are ready, and I'm going to show you. So and this video is going to be very interesting to know how this PN5180 works with the Mifare Ultralight tag. So you can see this software. It's in version 1.3, and some new things have been added. And if you're using this software, you have to flash your Arduino with the latest hex file. Now for the first few minutes, I'm going to quickly show you how to use this Mifare Ultralight screen. If you have used my softwares on A0122U or PN532 or Arduino MFRC522, so you will already know how to use my screens. All these screens, they're all identical across various boards. So the first thing you do is choose the Mifare Ultralight, and I'm going to place. This is not a brand new, and you have to keep in mind it's not that easy to buy Mifare Ultralight tag these days, because you already have the later version called Mifare Ultralight EV1. So if you can buy EV1, please go ahead with that. Don't wait for Mifare Ultralight. So looks like they are pretty outdated without any password or without any security. So this is a very old tag. Now first thing you do is go and turn the RF on. Now after that, activate. Now you can see all the various commands. These commands are not the PN5180 commands. These are the interface commands. So this is the command used to talk to the software running in Arduino, which in turn calls the PN5180 library. So I'm going to show you how these commands are written, and probably you can enhance the board, enhance the Arduino with your own commands. So since there is no security involved in Ultralight, you just go and hit this read tag. This entire tag data is read here. You can see this tag has got 16 blocks, and each block has got 4 bytes. And also you can see all the various commands that are going here. Now again, you can see these are the interface commands. Now to read an individual block, you just go here, hit this R button. You can see that the read is done. So again, all read operations are 16 bytes. So please see my videos on Mifare Ultralight. Those videos are fantastic if you want to know how the Mifare Ultralight tag works. So in order to write, so at present you have to write through this part of the screen. Say I want to change the value of the block 9, and I want to change this as say 01, 02, 03, 04, and hit the write button. So if the block or a page is not locked, your write will be successful. You see this message here, and you can see the various commands going here. Just the 4 bytes of data which we just typed, and this is again here you got the page number, and this is the interface command called D8. Now, everything needed to write to a block is sent from the software to the Arduino. Now again, there's other things like OTP. You got some static locks. So please see my videos, and whatever you do in the OTP or lock bytes, you just have to use the same normal write command to write to the block. So if you want to use a 2-step write operation, so you're going to put a tick here. So if you put a tick and try to write to the same block, say write, so you can see that a different set of commands is sent. Say for example, I'm just going to do a simple write operation without this use compatible writing tick. Say write. So there are 2 interface commands here. One is called a D2 followed by the 16 bytes, and other one is the D8 followed by 4 bytes. So I'm running the software PN5180 made easy version 1.3, and also connected my board, you can see here. And this release has got a couple of enhancements. If you go and see the release notes, you have got for Mifare Ultralight as well as Mifare Ultralight EV1. But in this video I'll be showing only on Mifare Ultralight, and next video I'll show the differences in Mifare Ultralight EV1. So if you have seen my software written for A0122U or PN532, these screens are identical. So it doesn't matter which hardware you use, the screens are the same. So the first thing, I'm just going to have a quick overview of what you can do in this software. I'm not going to explain what this Mifare Ultralight tag is. First thing you do is set this RF on, and I'm going to place a very old Mifare Ultralight tag, because I don't think you can buy any Mifare Ultralight tag these days. You can only buy Mifare Ultralight EV1, the version 1, and it makes sense to buy the version EV1 rather than the old Ultralight, because Ultralight doesn't have any kind of a security. EV1 has got a password protection as well. So first thing you do is activate. Now as soon as activate, you can see the UID, the 7-bit UID of this Ultralight tag, and you can hit this button called read tag. You read everything, the entire 16 pages of data is read into the software. You can make some changes. So to make a change at this moment of time, you have to go here. So I'm going to change this as a 20, 21, 22 and 23. And if you want to know what's happening here, and hit this right, and you can see that all the commands that are exchanged between the Arduino and the software, and these commands, they do not relate to the actual commands used within the tag. These are the commands that go to the Arduino interface, and I'm going to show in a minute how exactly these commands are mapped to the library functions and eventually to the commands used by the tag. So as I mentioned before, the Mifare Ultralight is one of the simplest tag to learn. It has got just two major operations. One is to read the page, another one is to write the page. Even though you see features like the log bits or the OTP, so is whatever it is on the screen, you'll eventually be using just the read or the write operation. So I also got open in the Arduino IDE. This is the Arduino program running, and this is the main loop that receives the bytes from the software, and there is a series of switch statement which will compare the byte from the software, and it will execute the corresponding the library functions of PN5180. Say for example, if the byte says it's a write register, and eventually it's going to call the write register function of the library. I also have the source code of the library PN5180.cpp, and this is a library you can get from the GitHub. The only difference here is we have added few additional functions, and those functions you can see if you scroll down. So most of the functions are in the bottom of this page. The header files tells you all the new functions added, plus you'll also find the constants, hash constants for all the commands coming from the PC software. And this is the front end, which I also showed you in Arduino IDE here. So once you know how this the Mifare Ultralight tag works, the next thing is you have to understand how these things are put together. What are the commands that are used to work with the Mifare Ultralight tag. So I'm going to open the screen again. This time we are going to see the commands here, and also we're going to see what exactly is happening inside the Arduino. The first thing you do is you're going to activate. Because the tag is already activated, you can't activate again. I'm going to take it away from the board and put it back. Or you could have also first set the RF off, then again RF on. So we know the RF is already on. I'm going to hit activate, and you can see that the command that is sent to the Arduino is D0 followed by 00. So if you go to this the Arduino IDE, so D0 corresponds to, you have to open this .h file. So D0 corresponds to the command called fanetpy activate type A. I'm going to copy this and go to the CPP file, or go to the interface file. Now whenever the command is the activate A, if you look at here, so a couple of things are happening. Now this is the library functions called activate type A. Now you have to copy this and search in the .cpp file. Now you have to understand, if you know all the things that are going on here, so that means all the PN5180 commands used to activate type A. So I'm going to go through this slowly, step by step. The first thing the function is doing is load the protocol, because before you can activate a tag, you must initialize the board with the correct protocol, and the function used is called the load RF config with the value 0 and 80, and 080 corresponds to the transmission side as type A as well as the receiver side. The next thing is here is what you see here corresponds to what you also see in the documentation of Mifare Ultralight. I've gone through this document before when I explained about, briefly I've explained in my earlier videos how the activation is done. So it starts with REQA. Now the most important thing to know here is, so in order to send this REQA, you're going to send a command that is 7-bit, and also you have to make a note of whether the CRC is used in sending the command, as well as whether CRC is used in the response as well. So I don't see any CRC here. Compare this with any other command, like say for example, yeah, this is one of the example. See, this command has got a CRC and the response also has got a CRC. So if you come across the CRC boxes in the command as well as the response, you have to make sure your PN5180 is also set to auto-generate CRC. See, the CRC is auto-generated, you don't have to compute. As well as if you're getting a CRC in the response, you have to tell the PN5180 that the response has a CRC and it needs to verify the CRC. So if you go back to here, if you look at this command, there is no CRC in the command as well as no CRC in the response. So you have to tell PN5180 that not to compute CRC, and also in this case you have to also tell that you are going to send only 7-bit in the command, and in the response side you have to tell that there is no CRC in the response. So if you understand this concept, then you can easily understand what's happening here. So these two lines, it's the first command says that we don't need the CRC checking on the reception as well as no CRC computation on the transmission. So this is the mask. Next thing is, the first command, this is the anti-collision activation, that's the REQA or WPA. I'm using REQA. So here the parameter decides whether to use REQA or WPA. So this is the command. The send command is very much used in most of the commands, so you get comfortable with the send data. So send data, you're telling it to send the commands in this byte array. So here I got only one command, plus I'm telling it to send this. All these, there's a function called send data. If you go and search for send data somewhere up, this is part of the library where you send the array of bytes as well as the length of the bytes. Plus, this is the most important thing. You are telling the send data function to use only 7 bits. So this is what the documentation says. So afterwards, you are reading the A2QA, the response of REQA, and after that, this is where the anti-collision 1 starts. Again, you have to follow the documentation. 9320, you're going to send 2 bytes, but this time you have to send all the 8 bits, so this is set to 00, whereas here we want to send 7 bits, it is set to 7. So 0 means all the 8 bits. So again, you have to make sure that when you try to read here, the next command is the anti-collision 1. So before you send this command, if you see the documentation for anti-collision 1, in the anti-collision 1, so you don't need a CRC while sending the command. However, so I think yeah, that's all. So you don't need any CRC here. So if you look at this, what the software does here is, so this is part of the same steps here. So the CRC is disabled for both the transmission and the reception, and all these things are happening without the CRC. However, the command called select anti-collision, so if you look at this select anti-collision 1, so this command, yeah, this is the command. So to send this command, you have to have the CRC in the command, as well as you have to check the CRC in the response. So you have got both the CRC present in the transmission as well as the reception. That's exactly what these two the write register does. It's going to set the last bit of the CRC. If you look into my the console in the software, you can play with this mask. So again, you send all these bytes here. You have to send 7 bytes. So because you just have to follow the data sheet. So in addition to this command bytes, you also need to send the 5 bytes which is received in the command before. So this is just it's a very generic thing happens during the type activation. I've done so many videos using a CR95 chip explaining this in detail. So what you have to keep in mind here is this code follows the standard algorithm to activate a type A and to identify whether it is a 4-byte tag or a 7-byte tag. Now the most important thing here is for your knowledge here is that you understand that whether to enable the CRC or to disable the CRC. And you can't decide like this. You just have to see what the documentation says. In any command in this data sheet, if you don't see the CRC in the command, it means you have to disable the CRC. As well as if you see the CRC in the command or response, you have to make sure that you're going to enable the CRC. Now by default, when you load this configuration for type A, the CRC for both transmission side and the reception side are both enabled. And that's the reason why I disable here before I send all the commands. And also make sure just before you come out of this function, okay, you are enabling this CRC. So otherwise some of the commands may not work at all. So that is what you need to know about activation of type A tags. The next interesting thing is about the read and the write. So these are the only 2 commands you have to understand. So I'm going to hit the read. You can read the entire tag content. However, this time I'm just going to read a single page here. If I click this link R, so the command that is sent is D1 followed by 06. So for the first thing you're going to do is identify what is D1. Go to the .h file. This is your starting point. The D1 corresponds to this command called, it's a constant name called /py Mifare block read. If you Control C and if you Control V and search here, and this corresponds to the case statement here. And what this does is it's going to call the library function called Mifare block read by passing the block number or the page number to read and also the response array where the data is collected. After that, after successful execution of this command, the 16 bytes is sent back to the PC. So if you come across this function called send response to PC, which is defined somewhere down the source code, you'll come to know that it just transfers byte by byte the 16 bytes from this array. So you're going to see this function called Mifare block read. Control C. I'm going to search. Okay. Now this here again, you'll be using, as I mentioned before, you're going to use this send data command a lot. So we have started to send the command specific to the tag. The read tag, in order to read something from this Mifare Ultralight tag, you have to send the command 30 address followed by the CRC, and you don't have to worry the CRC because it's enabled now. And in response, you get 16 bytes followed by the CRC. So I have to send this 30 and 80. And look at that, how easy is that to program in Mifare 5180. So I'm building this array of commands. I'm sending 30 followed by the block number which is passed here, send data. Now somehow, what I've seen is you have to give a small delay before you start reading from the data. And keep one thing in mind, the way this tags works is, this is the tag, this is the ultralight tag, and this is the PN5180, and this has got a transmission buffer, TX buffer, and this has got a RX buffer. Now the commands, this is the host. The command, these two commands are first transferred to the transmission buffer. From here it goes to Ultralight, and this is processed here, and the 16 bytes response will get into the RX, and this is from here the host will read and send this data to the PC. So just after you send this commands, you have to give a small delay. There could be some other way to find out, rather than find out whether the data is available or not, but at this moment of time I'm not sure, so I've introduced a delay. And in fact my developers have seen this delay right from 1 up to we started with the number 10. It's a 10 microsecond, but we are able to see that a delay of 1 should be enough. Okay, 1 should be enough to read the data. There's one more function here called RX. See, this is the function. This is a very interesting function here. If you search for this, look at that. This function, in fact, what it's trying to do here is, there is a register called RX status register, and if you read the content of the register and get a mask of the 9 bits, it will tell you how many bytes are awaiting in the transmission, in the reception buffer. And probably you can put a loop looking for whether the enough data is available in this register. This is one way of getting to the delay statement. So you're going to read how many bytes I have received, and we know that the read block command has to return 16 bytes. So only when the length is 16 bytes, you're going to copy the 16 bytes. Again, in order to read the data from the reception buffer, you have to send this read data command. This is the standard library function which is somewhere in the file. Now this command calls the read data of PN5180, read 16 bytes and transfer to buffer, and returns it true. So you just have to understand in this bit. Probably we'll be revisiting this in my future videos when I discuss about NTAC 213 or some other attacks. The next that's pretty interesting is the write command. Now I'm going to write something to page number 7. So here to write, I'm going to change something to 33, this is something like this, and hit the write. And you can see that the command is D8 followed by the block number followed by the data. But what you get is pretty interesting. You get this command called 0A. Now if you go to the documentation of Ultralight, now this is the write command. Now this command, so sorry, just something is covered up here, but what this command does is, this command will return either acknowledgement or negative acknowledgement. So this is going to return us only 4 bit of data. If you see this documentation further, probably I'll show you what this acknowledgement is. So I'm not able to find this information in Mifare Ultralight, but however you can get that from Mifare Ultralight EV1. Now this is the same, it's the same write command, it's the same write used in Mifare Ultralight, works also with Ultralight EV1. You can see here, for the write command to work, you have to send the command address followed by the 4 bytes of data, and also there's a CRC, so make sure you enable the CRC bit. But in the reception side, there is no CRC, and also you don't get a full byte, you just get a 4 bit. You have to make sure that you are able to configure to receive only the 4 bit, not 8 bits. So you either get ACK or NAK. So it's supposed to be NAK, not NACK. It's a negative acknowledgement. And if you click this table 10, these are the values for the response. If you get a 0A, it means the write is successful, or any command that relates to this has been successful. This is acknowledgement. If you get any other number, so I have seen getting 0A if indicates invalid argument or the write did not work. So you should look for the return value for 0A in order to make sure the write is successful. So again, it's as simple as that. Now to understand what is happening inside the Arduino, you just have to first find out what this D8 corresponds to. Go to the .h file, look for the D8. It is this one. It's called the Mifare block write 4. Control C. First make sure that you understand this switch statement. Now whenever this command is received from the PC, it's going to call the library function called Mifare block write 4. Go here and search for this. So look at that. So this, on the reception side, you're not going to receive the CRC, so I'm disabling that. I'm clearing the last bit, so which is done by this command. So I'm building up the command with A2 correspond to write the block number followed by the 4 bytes of data, and altogether I've got 6 bytes. The 6 bytes is sent using this send data command, and also now I'm not using this number of bits, it's set to 8, and here somehow I'm not sure why we got the delay 10, but one thing we have observed is you have to give a delay before you can read the acknowledgement. Now when you read here, you're reading just 1 byte. So when you read this 1 byte, now whatever data get in the byte, I'm returning as a function. So either you get 0A, and just make sure before you exit this function, you enable the CRC. So it's very, very simple. So you just have to understand that the response for a write data is just the ACK and AK. So I'm going to show you something more interesting, the way these bits, are going to save with my console application. So there are a couple of interesting things, you can witness using this software. Now what I've just done is I've removed this tag, and also going to turn off the RF. Now start this console. I'm going to, if you go to the registers tab and look for the register called the RF status. This is the radio frequency status, RF. This is the antenna side basically. Now read. Now as you can see here, there are things which I don't understand, all these things related to the antenna design. So I'll be more interested in this the TX RF status. So this tells you whether the antenna here is powered or not powered. Okay, so and also there are a couple of other simple things here. Say for example whether the CRC computation is correct or not. Now if you go to this configuration, the commands, click on this RF on. Now we now know what is this RF on does. Now it just calls the RF on a simple as a one-to-one mapping, what you see here and what you see in the library. Go to the register and go to the RF status, hit the read command. Hit the read. You can see here that TX RF status is ticked. So this shows the antenna is on. So you can use this this feature if you want to know if the antenna is on or off in your system. You just have to go and read the value of RF status register and look for the bit number 17. So how easy is that? Okay, now the other thing I would like to show here is, now I'm going to activate, I'm going to show the 4-bit ACK and NACK, what happens, and a couple of other interesting bits. I'm going to activate, so I'm going to read or write to block number 5. Block number 5. So probably now maybe this is not the best place to try, so I'm going to use the commands for that. Okay, I'm going to send this command, the write command, the send data command 00, and if you remember the write command, so I'm using this Mifare Ultralight EV1 because we know it's the same command structure. So look for the write command. Okay, this is the write command. I have to send A2 followed by the address. I'm going to say A2. I'm going to write to page number 05, and I'm going to set the value as 11121314. Now if you hit execute, you get some response here. Now let's see what's happening within the system. We have just finished sending this. The write command, CRC is fine, but we are expecting a negative acknowledgement without the CRC. However, we did not disable the CRC for the reception, but let's go and see what has happened. Go for the register called RX status. This is the received side, the reception status. Click on the read. There's some interesting things that happened here. The first and foremost is there is a error flag set. It says RX data integrity error. It is because the response did not have the CRC, but PN5180 tried to check for the CRC. Obviously it's an error. That's one thing. So the next thing is these 3 bits are interesting. These 3 bits tell you how many bits are present in the response. So this is in a bit 0, bit 1, bit 2. This is set to 100. So if you convert this to the binary, we have a bit 100, and this is nothing but the decimal 4. So if you want to know how many bits of data you received, look for RX status and look for these 3 bits. So here it's 4. I know I've received 4 bits, but there is a CRC error. Now how do we get rid of that? So I'm going to try the same command again, but this time, but before you do that, probably now you can finish this by reading. Sorry. So go and see, read that 1 byte. So you will get FF. This is because there was a CRC error. Obviously the data I received is something wrong. Now what I'm going to do next is I'm going to set the disable the CRC check on the reception side. So to do that, you have to go to CRC RX config, read. These are the current values. Now I'm going to reset this. I'm going to do the AND operation. Select all, remove that, get the write mask here, use this write AND operation here. So write. Now I have got the CRC on the reception side disabled. So do the same command again. This time send data. Sorry, just to clear this thing. Now send data 00 and A2 05 11121314 and execute. Now you go to the registers, look for RF status, read. Now you can see that here there is no error. Oh sorry, not this one, I was wrong. Go to RX status, read, and you can see that there is no error. However, you can see there are 4 bits I've received, and now if I go and try to read the 1 byte of data, read and 1 byte, execute, you can see that you get a 0A. How cool is that? So to be honest, okay, this chip P5180 is much easier to program compared to the P1532 or PN532 or MFRC522. So I think that's all I got in this video. We are going to go through this process of checking the registers and checking what's going to happen within the Arduino and within the commands in all my future videos. So the next video will be on the Mifare Ultralight EV1 and a couple of interesting commands you're going to see there. Okay, thanks for watching.